Welcome back, everyone. We're going to be solving LeetCode 94, binary tree in-order traversal. So given the root of a binary tree, return the in-order traversal of its nodes values. And we can take a look at example 1. So they give us 1, 2, and 3 as our tree, and they want to return 1, 3, then 2, which would be the in-order traversal of the nodes of the tree. So we're going to run depth first search on this. So we're going to need a stack. And on this stack, we are going to use a tuple with the root and a visited value. We will say we have not visited our root node yet, so we will start off with false. And they obviously want a returning resulting array, so we'll say res is going to be equal to an empty array. And for depth first, we want to run our algorithm while our stack still has nodes on it, so while the length of stack is not equal to 0. What do we want to do? We want to grab the node and the visited status. Okay, now what? Now we need to check and make sure that our node is not null. So we'll say if node is not none, we want to do something. What do we want to do? We want to check the visited status. And if it's true, we want to append the node value onto our resulting array. So if visited is true, we'll say res.append node.val. Otherwise, if visited is not true, we need to append our nodes onto our stack. So we'll say, and we need to check and make sure that the left child and right child are non-null. So we'll say if node.right is not none, we want to say stack.append the tuple of node.right along with the visited status of false. We'll do the same for the left side. So if node.left is not none, stack.append node.left and false for visited. And we want to do an in-order traversal. So we want to append our current working node in between our right and left child. So we'll say stack.append the current working node along with a visited status. We're going to change it to true now because we've already visited it. And that should give us our in-order traversal. So we can return our resulting array once we exit this loop. So let's run this. And we do pass all 3 test cases. We'll submit. And it does pass the submission cases. So time and space complexity. Time complexity is going to be O of n, where n is the number of nodes in our tree. Right? We have to traverse all of the nodes and append their values to our resulting output. And the space complexity is going to be, it's going to depend on the length of our stack plus the length of our resulting output. So we can say stack.length plus res.length. And that'll do it for LeetCode 94.